This week for our Evap lab, we're going to be taking a look at a 2007 Buick Lucerne. And here on All Data, it is showing our purge solenoid up by the intake manifold and how that is going to be going to the canister under the car. So you can see with our hoses coming in here. This is a better view, but here's our pressure sensor and more connections in the back to our other solenoid and our gas tank. Here is that other solenoid I was talking about, and unlike some other cars with it being remotely mounted, this one is mounted on top of the canister and is very close, unlike other cars. After taking a look on All Data, I'm going to be showing you it here on the car. So here's our purge solenoid. You can see those two wires down there, and here is our service port used to smoke test the Evap system. And then now we're going to take and follow this line all the way down to the underside of the car and show you everything else. So now that we are under the car here, you can see these three hoses coming in. That middle one is actually connected to that purge solenoid that we just came from the front of the car. This far one is connected to our gas tank and to our charcoal canister here through that filter. And then this one over here is to our fresh air, technically, and that second solenoid we have in the system, which is above the canister here. I don't think you can see that, but it is up there.
Now in this top-down scan tool, we're going to be looking at our live PID readings for our Evap system. Our evaporative emission vent solenoid is right now venting. It's open, and it will stay open until we have to run an actual Evap test and see how much pressure our system can hold, or vacuum our system can hold. Our purge solenoid command is at 0% right now. We can increase and decrease that as we go on. And our fuel tank pressure sensor is reading negative 0.15 mm of mercury. And that's equating to about 1.43 volts on the sensor reading. If I increase this reading right here, I press increase, we can command it to 10%. And if we walk over to the vehicle, we can hear it actively pulse width modulating that solenoid, so we have 10% duty cycle. So with our vehicle sitting here at idle, our 2007 Buick Lucerne, we're actually getting a good amount of usage from the Evap purge solenoid, and we're commanding it from about 14 to 20%. And we were gonna look at our short-term and long-term fuel trims, how they changed as we increased the purge solenoid command. But here at idle, sitting in this vehicle, it is being commanded already. So we can look at our trims and we can impact them from that point. But I wanted to point out that we are getting a purge solenoid command at idle. So let's decrease that reading. Let's make it 0. The vehicle, you can hear it running a little awkward now. And we're taking some fuel from our short-term fuel. We're cycling. Our long-term fuel trim seems to stay the same. Let's increase that percentage again. Let's get 20%. Immediately our long-term fuel trim just shifted over. Our short-term fuel trim is still trying to figure out what it wants to do. It's at 0.781. So it's cycling, it's switching. But the second we increase that command percentage of our purge solenoid, our long-term fuel trim accounts for that and goes down. So if I decrease it to 10, you see our short-term fuel trims are doing a lot more now. We're taking away a lot of fuel. Still taking away fuel. Now we're back to where, still taking a lot of fuel. Take it all the way down. Our long terms just switch back super high, or much higher than they were. and our short turn starts to do less. So, food for thought. Just wanted to show what the vehicle is doing and how impacting the purge solenoid command altered our fuel trims.
So here we have removed the purge solenoid from the intake manifold here, as you can see off the hose connector and right there with one bolt. And we are now looking at it here, and we got it hooked up for an ohm test. Everything looks good on it. O-ring looks good, and as you can see, 21.23-ish ohms there. Solenoid is looking great.